Hello everyone, welcome back to Physics online classes for class 11 students. Let us continue chapter 2 units and measurement. Today we are going to study about significant figures part 2. In the previous class we studied what are significant figures and what are the rules to determine the number of significant figures. Before going to continue significant figure part 2, let us revise once what we have studied in the previous class. So first we have to know what is significant figure. Remember, significant figure means all accurate values, that is all certain digit plus one doubtful digit. Doubtful means uncertain, whose value is not much accurate. All accurate digit plus one doubtful digit, that gives significant figure. So in the proper way, we can define significant figure as the digits whose values are accurately known and the first uncertain digit in a particular measurement are known as significant figures. Right? For example, if I am going to consider the length of the object is found to be 127.6 centimeter. I had given the same example in the previous class, you can remember. 127.6. Here totally there are 4 digits. How many digits are there? 4. 1, 2, 7, 6. The number is 127.6. Here the digit 1, 2, 7. These are accurate values or certain digits. But the number 6 is uncertain. This is doubtful digit. So we are going to consider only all accurate digit plus one doubtful digit. So in this number 127.6, here totally there are 4 significant figures. 1, 2, 7, 6. 1, 2, 7 are accurate digit and 6 is the first uncertain digit. So this is significant figure. After that we studied the 5 rules to determine number of significant figures. So this significant figure concept is very important. You can go for any competitive examination or in any board examination. The one question will be on significant figure. The question will be like this: how many significant figures are there in the given number? You have to find how many significant figures are present. So that time these 5 rules are very important and you have to remember. What is the first rule? The first rule is all the non-zero digits are significant. All the non-zero digits are significant, means except 0, remaining all are significant. Second rule, all zeros between the two non-zero digits are significant. Suppose the number is 306. 0 is lying between 3 and 6. So we can consider as significant. Then third rule, all zeros to the right of the last non-zero digit are not significant. If the zeros are on the right side of the non-zero digit, then we are not going to consider as significant. Then fourth rule, for a number less than 1, if the number is less than 1, then the zeros on the right of the decimal point but to the left of the first non-zero digit, they are not significant. Then last rule, all zeros to the right of a decimal point and to the right of a non-zero digit are significant. So I had given many examples to understand all these 5 rules that we have studied in detail in the previous class. Now let us continue significant figures part 2. So in today's class, we are going to study about the rules for rounding off the numbers, how to round off the numbers. While rounding off the numbers, what rules we have to follow, that we can study in the today's class. Totally there are 4 rules for rounding off the numbers. Now you can observe the first rule. The first rule is if the digit to be dropped is less than 5, then the preceding digit is left unchanged. See here, the first rule you can easily understand by seeing this example. You can observe this tabular column. Go for the first example. The number is given 1.83. What is the number? 1.83. Here, according to the rule, if the digit to be dropped is less than 5, that means this last digit it is less than 5. The number is 3. 3 is less than 5. If the digit to be dropped is less than 5, that means the last digit, if it is less than 5, then the preceding digit, that means 8. This preceding digit is left unchanged. That means while rounding off the number, if the last digit is less than 5, then the preceding digit remains the same. That is not increasing or decreasing, it remains the same. 1.83. After rounding off, it becomes 1.8 because 3 is less than 5. So, the preceding digit remains unchanged. The digit to be retained means that preceding digit number 8 that remains constant when the last digit is less than 5. Is it clear? What is the first rule? If the digit to be dropped is less than 5, then the preceding digit is left unchanged. You can observe one more example. The number is given 2.462. Now, the digit to be dropped is 2. This number is less than 5. When it is less than 5, then preceding number remains the same. So, after rounding off, we can write 2.46. This is the first rule. Is it clear? Now we can study about the second rule. If the digit dropped is greater than 5, if the last digit is greater than 5, then the preceding digit is increased by 1. Remember, when the last digit is greater than 5, then the preceding digit is increased by 1 while rounding off the numbers. You can observe the example 4.56. 6 is greater than 5 when the last digit is greater than 5. While rounding off the number, the preceding digit is increased by 1. Now you can observe 4.56 is the given number. After rounding off, 4.56 becomes 4.6 because we are adding number 1 to the preceding digit 5. 5 plus 1 is how much? 6. Then observe another example, 8.248. The last digit is greater than 5. When it is greater than 5, then the preceding digit is increased by 1. So, after rounding off, this number will become 8.25. Is it clear? The first rule is when the last digit is less than 5, it remains the same. Second rule, when the last digit is greater than 5, then the preceding digit is increased by 1. Then come to the third rule. If the digit to be dropped is 5, if the last digit is exactly 5, then the preceding digit is left unchanged if it is even. Remember, if the last digit is 5, it is not less than 5, greater than 5, it is exactly equal to 5. Then the preceding digit is left unchanged. That means preceding digit remains constant only when it is even number. So you can observe the example 8.65. 5 is last digit, it is exactly 5. When it is exactly 5, then the preceding digit, if it is even, then it remains same. Is it clear? It is not increasing, decreasing. So, the last digit, if it is exactly 5, then the preceding digit left unchanged if it is even. Is it clear? Then go for the second example, 7.45. Last digit is exactly 5. So the preceding digit, this is even. Even means that remains same. 7.4 after rounding off. The first rule, we take less than 5. In the second rule, we consider greater than 5. In the third rule, we consider exactly 5. But the preceding digit, if it is even, it remains constant. Then come to the last rule to rounding off the numbers. The rule is, if the digit to be dropped is 5, then the preceding digit is increased by 1 if it is odd number. If the preceding digit is odd number, then only it is increased by 1 if the last digit is exactly equal to 5. Observe the example. The given number is 8.35. Here you can observe 5, it is the last digit, it is exactly 5. Then preceding digit you can observe, this is 3. 3, whether it is even or odd, it is odd number. When it is a odd number, then it is increased by 1. So after rounding off, we can write 8.4. If it is even number, it remains constant. But it is odd number, so according to the rule, it is increased by 1. Then second example is 3.75. 5, the last digit, it is exactly equal to 5. So come to the preceding digit. It is an odd number. Odd number means it is increased by 1. So the final answer should be 3.8. This is not 3.6. 3.8. If the preceding number is even, it remains same. If the preceding number is odd, it is increased by 1 only when the last digit is equal to 5. So these are the 4 rules for rounding off the numbers. Is it clear? What is the first rule? If the digit to be dropped is less than 5, then preceding digit remains unchanged. Second point, if the digit to be dropped is greater than 5, then the preceding digit is increased by 1. Third rule, if the digit to be dropped is exactly 5, then the preceding digit left unchanged if it is even. Then the last rule, if the digit to be dropped is 5, then the preceding digit is increased by 1 if it is odd number. So these 4 rules you have to remember while rounding off the numbers. Now we can study significant figures in algebraic operations. Algebraic operation means in addition, subtraction, multiplication and division. How to find significant figures. Now you can observe significant figures in addition and subtraction. In addition and subtraction of the numerical values, the final result should contain the same number of decimal places as the number with least decimal places. So this statement you can understand only with some example. See here, according to addition and subtraction operations, in significant figures, here whenever you are going to add two numbers, whenever you are going to subtract the numerical values, whatever the final result we can get, that final result should have the same number of decimal places as the number with least decimal places. Remember, now I am going to consider the number 23.592 and 12.6. You can observe these two numbers. I am going to add these two numbers. What are the numbers here? 23.592 and 12.6. We are going to add these two numbers. Now, I can get after adding the numbers, the final result is 36.192. This is the final result. Now, according to significant figure rules in algebraic operation, here the final result should contain the same number of decimal places as the number with least decimal places. That means, now you can observe these two numbers. The first number is 23.592. Second number is 12.6. Out of these two numbers, which is having least decimal places? That means after this decimal point, which number is having least digits? In the first number, totally there are 3 decimal places. In the second number, only there is a 1 decimal place. Got the difference? Now, out of these two numbers, which is having least decimal places? 12.6 is having least decimal places. So, in the final result, it should have the same number of decimal places as the number with least decimal places. Here, which number is having least decimal places? In the final result also, we have to consider the least decimal places. That means, the answer is 36.192. The final answer should contain least decimal. What is the least decimal out of these two numbers? 1. So, I want only 1 digit after decimal point. Right? Now, the answer is what? 36.192. 36 point. I am going to drop these two numbers. I am going to leave it because we want only 1 decimal places. Right? Now, 36.192. 9 is greater than 5. So, here the previous number is increased by 1. So, I can write 36.2. What is the final answer? 36.2. Why we are neglecting 9 and 2 here? Because in addition and subtraction, you can remember whatever the numbers are given, out of these numbers, first we have to observe which is having least decimal place. Here 12.6, only there is a 1 decimal place. So the final result should also contain only 1 decimal place. After rounding off, the final result we can get is 36.2. Is it clear? You can observe out of the given two numbers to be added. Here, out of these two numbers, 12.6 is having least decimal place. How many decimal place it is having? Only 1. This is least decimal place. According to the rule, the final result cannot have more than 1 decimal place. Therefore, the digit 9 in the second place of the decimal should be dropped and the preceding digit 1 should be increased by 1. So, the final answer we can get 36.2. Is it clear? In addition as well as in subtraction, whatever the numbers you are going to take, first we have to find which number is having least decimal places. So that after adding or after subtracting, the final result should also contain least decimal place. Is it clear? Now, you can observe subtraction. Let us find difference between two numbers. The numbers are given 428.5 and 17.23. Now tell me, out of these two numbers, which is having least decimal places? 428.5. So this is having only 1 decimal place. Here 17.23. So these are having 2 decimal places. After decimal point, how many numbers are there here? 2. Here after decimal point, it is having only 1 decimal place or only 1 number. Now tell me which is having least decimal place. So this number is having least decimal place. Right? That means after subtracting these two numbers, the final result should contain the least decimal place, that is only 1 number we have to write after decimal point. Now let us subtract these two numbers. The numbers are 428.5 minus 17.23. So after subtracting, we will get the final answer 411.27. Now observe the final result. After decimal point, there are 2 digits. But according to the rule, we should write only one decimal place. So now tell me, after rounding off, what is the final result? 411 point. So 7, it is greater than 5. We have to drop this 7 number so that preceding number is increased by 1. So the final answer I can write 411.3. Right? Out of the given 2 numbers to be subtracted, 428.5 is having least decimal place, that is only 1 decimal place. According to the rule, the final result cannot have more than 1 decimal place. Therefore, the digit 7 in the second place of decimal should be dropped and the preceding digit 2 should be increased by 1. Hence, the final result we got 411.3. Is it clear? So, you can observe for addition and for subtraction, the rule is in terms of decimal places. This is very important. Whenever you are going to add or subtract numbers or numerical values, the rules we have to follow only in terms of decimal places. Decimal places means the digits after decimal point. Here in addition and subtraction, we have to consider least decimal places, means least numbers after decimal point. This is all about addition and subtraction. Thank you.